All right, guys. As promised, here's video number three. Let's talk about balancing redox reactions in acidic solution. And oh boy, this is where it gets just a little bit more difficult, right? Now, look, if you still follow the same steps, it should still relatively be kind of the same thing, but there's some extra steps that we need to take. Most importantly is because if you notice, wait, there's an oxygen over here, but there's none over here. So how do we rectify that? Well, there's a way for us to do that. And by the way, for the purposes of this class, I will always let you know if it's an acidic solution or not. Because in reality, if you're doing this reaction in real life, you'll know if it's acidic reaction or if it's in basic solution. You'll always know. All right. So here's how we do this. So for the first part, we're going to actually do this exactly the same way that we've done all of these so far, right? We're going to assign oxidation numbers. We're going to split them up into half reactions, both the reduction reaction and our oxidation reaction, right? And then we're going to balance out charges, okay? The difference is that we also have to balance the matter, just like we should have done before, but just a little bit different now. All right, so let's take a look at this reaction. So it looks like we have permanganate. We're going to add it to some iron ions, right? And then we're going to react and it's going to produce manganese ions and iron ions. Okay. So the first thing we're going to do, we're going to start assigning some oxidation numbers. I'm going to do this my fast way just because to make sure we got the same thing. So just like we talked about before, because we have oxygen right here, whatever it equals to has to equal to -1. So it's going to be -2. Let me zoom in a little bit so you can see this a little bit better. Right, a little bit cleaner so you can actually see it. -2, because it's always going to be -2 for the most part. Okay. And we're going to multiply that by 4, which is going to give us -8. Now, manganese in this case, if we add it to manganese, right? Manganese needs to give us an oxidation number that's going to allow us to have -1, right? Well, if 4 times -2 is -8, in order for that to be the case, this has to be +7. Put a +7 right there. Okay, so our oxidation number for manganese is going to be +7. Our oxidation number for oxygen is going to be -2. If I add those two up, that's going to give me a charge of -1. Wait, is my math right? Yes, it is, because it's -8. Okay, good. So making sure it's the right thing. Now, iron, it's pretty simple because it's an oxidate, it's already oxidized, so therefore this is going to be +2. I'll write a +2 right above it. +2. There's that one. Now let's go jump over here to the product side. Manganese, pretty simple. That's +2. Iron, pretty simple. That's +3. All right. So let's take a look. Let's see what's being reduced and what's being oxidized. Don't forget our little lion here. Leo the lion goes grr. Give him little teeth. Give him some hair. And don't forget his eyeball. There you go. That time it doesn't disappear. Leo the lion goes grr. So whatever is losing electrons, that's our oxidation reaction. Whatever's gaining electrons, that's our reduction reaction. So let's take a look. So we're going to take mainly a look at manganese, which here is a +7, and over here is a +2. Well, it went from big positive down to not as big positive. So therefore, it's gaining something a negative, which is in this case of those electrons. So this right here, ladies and gents, boys and girls, is going to be our reduction reaction. I'll put an R right there just so you can see. Okay, for reduction. Then we're going to take a look at the next thing, which is going to be iron. We're not going to look at oxygen all because we don't care about oxygen. All we care about is the metals here, right? Oxygen, or sorry, iron, after I told you guys not to care about it, goes from +2, right? All the way to +3, meaning that it became more positive, which means that it lost electrons. So this is going to be our oxidation reaction. Okay. So this is going to be our O. All right. Now that we've established what's being reduced and what's being oxidized, now we're going to do the same thing that we did before, and we're going to split this up into two half reactions. The first reaction, just because I'm weird, I always like doing the oxidation reaction first because I feel bad for it. I mean, I lost all those electrons. So I'll let it go first. 2 plus. And it's going to react to produce, let me actually just give myself a little bit more space here. It's actually going to produce iron ions. Now, I'm going to balance the electrons right off the bat because I don't want to waste time right now. So we're going to do that real quick. Then I'm going to get to the other one. Okay. So just by looking at this, first step I'm going to ask myself is the matter balance? It is. I have one iron on the left-hand side, one iron on the right-hand side. Great. Well, what about the electrons? Well, on the product side, I have a +3 charge. On the reactant side, I have a +2 charge. Well, that don't work. So what does that mean? I got to make them equal to each other. So that means I have to add an electron over to the product side to make sure these two sides are balanced out. Now, like I told you guys before, if it's oxidized, you will typically put the electron on the product side of the reaction, which is what we're going to do right now. So we're going to add how many electrons? One good old-fashioned, hardworking American electron right there. Just one of them. Okay, cool. My matter is balanced. My charges are balanced. Oxidation reaction, G2G, good to go. Okay, let's get to our reduction reaction now. A little bit more difficult, but still pretty much the same. So I got my manganese, or sorry, permanganate ion. Love that one. Permanganate. So much fun to say. O4. Okay. And it's going to react to produce manganese ions, which in this case is Mn. Mn. Sounds funny when you say it like that. Mn. 2 plus, just like that. Okay. Now, first thing we do, we balance out matter. Well, our manganese are balanced, but wait a minute, Mr. Dominguez, there's some freaking oxygens over there. What do I do with that stuff? What am I going to do? Well, when you are balancing in an acidic reaction, the only way to balance out your oxygen is you must add water. So, in order to do that, since I have 4 oxygens over here, I'm going to add 4 waters to the product side over here. So I'm going to say H2O, and we want specifically 4 of them. Okay. You're like, cool, Mr. Dominguez, I added my water. Now I can start doing electrons, right? No, you cannot start doing the electrons just yet. And the reason is because all of a sudden, I have all these hydrogens over here. Oh, that's not good, right? So now I got to add hydrogens over to the reactant side. And you guessed it, because this is an acidic reaction. What makes something acidic is the addition of hydrogen ions. Okay, so this is how we know it's acidic. So in this case, because I added 8 over here to the product side, I'm going to add 8 hydrogen ions to the reactant side of the equation. And just like that, my matter is now balanced, right? I have 8 electrons on the reactants, or sorry, let me try one more time. 8 hydrogen ions on the left side, right? 8 hydrogen ions, or 8 hydrogens on the product side. My manganese are good, 1 and 1, and my oxygens are also good because I have 4 and 4. All right, great. Now we can get down to balancing our charges. Now, what I like to do is I like to put charges above, right? Just to make sure I got the same amount. So over here, there's nothing here in per well, this actually there is. It's a negative sign. Duh. See, I almost forgot. So you got to remember to put your negative signs. If not, things get messed up. Is there negative? Yeah, there is. Okay, just making sure. So if I add all these up, this gives me a grand charge of positive 7. Okay, on the reactant side. On the product side, since the only thing that has a charge is going to be my manganese ion, which is positive 2, just like that. Okay. Now, if I take a look at this, they're obviously not balanced, right? I have way more positive on the reactant side than I'm on the negative side, and there's a difference of about 5. Now, since it goes from being 7 down to being positive 2, that means that I'm gaining those electrons because it's becoming more negative. So I'm going to add those electrons over to my reactant side of my equation, and specifically 5 of them. All right. So just because I want the space, I'm going to rewrite this one more time, just because, well, yeah, let me move this arrow actually a little bit. Beauty of digital things. I can just move stuff. Let's move it over here a little bit closer, right there. And I'm going to write 5 electrons right here. 5e negative, just like that. All right. Now, charges are balanced. Everything's good to go, right? Except for one thing. Remember, I'm trying to get rid of these electrons, okay? Because I want to balance redox reaction. Well, you notice down here on the reduction reaction, I have 5 electrons. But up on the oxidation reaction, I only have 1. So I have to, kind of square that circle, as they say. So I'm going to multiply the top part all by 5, so that way the electrons are equal to one another. Because ultimately, that's what I want to do. I want to make sure my electrons are equal to one another. So I multiply the whole top reaction by 5. I'm going to write this in pink so you guys see what I'm talking about. 5 here, because 5 times 1 is 5. 5 right there. And now I have 5 electrons. Now what I'm going to do is I'm going to add up both of my reactions to one another. Remembering, what the heck was that? That both of these are divided by split line. Okay. So whatever's on either side of the reactions are going to end up canceling each other if they're the same amount. If they're not, then you're just going to subtract the 2. Okay. So we take a look right here at our electrons. Those are all good. So those go away. Gone. These go away. Gone. Right, so now my electrons are good. Is there anything else I can cancel? No, because iron's good on both sides, so we're fine. Manganese is good, my hydrogens are good, my waters are good, so everything's good. So I just add everything up, okay? So when I add everything up, here's what I get. I get 5 iron ions, iron 2 ions, plus my permanganate, only one of them, O4, negative, plus, and don't forget my good old hydrogen ions, H plus. Remember, this is an acidic solution, so you expect there to be hydrogen ions somewhere. And it will produce 5 iron ions, 3 plus 1 manganese ion, Mn 2 plus. And don't forget about our lovely waters that we made from this, 4H2O. And just like that, ladies and gentlemen, boys and girls, you have a balanced redox reaction in, wait for it, an acidic solution. All right. So you can see there's only like really one step that I added here, and that is to just add water and hydrogen ions to balance my oxygens that are somewhere in the reaction. Okay. Now, I'm going to warn you guys that sometimes it's going to be in basic solution, and that requires another step. But I will let you guys know right now that you handle it almost exactly the same way as an acidic reaction, except for one difference at the very, very, very end. And that'll be the final video that I make for this. Can we call it a series? Fine, let's call it a series. All right, guys. Until next time, see you guys later.